So we will start with the static keyword. So in this, if I have a class and if I have a display function, so I will not be able to call this function directly. Like I can't call this as display. It will throw you an error because we have to create an object of this. And then we can call this function by using this object, OB. But if I want to have a provision of calling it directly, then what I should do? I'll remove this off. I'll make this as static. So when I do this, I'll be able to call it directly. Now, this is an example of this class being a part of static example, which has the main function. What happens in case if I have a separate class, let us say here, I have something called as class example. Okay. And this is a part of example class. Now, how do I call this function? Now it is going to throw error because display is not a part of static example. It is a part of the example class. So at that point of time, you need to call it using example dot display. Okay. Whenever you use static, if you have written any function within that class which has the main function, you can use the display directly because it is part of your own class where the main function is also one of the function of static example class. But just in case if there is separate class which has, let us say, void display, but it is not just any other member function, it has static keyword associated, then this whole thing is not part of individual object. It is the part of the class. So whenever you're calling it, you are calling by class name, that is example dot display. One more thing is if I have, let us say, static int count. Okay. So I'm going to give it as 0. Now, what happens with the static count? Now, how, with respect to display, you're calling the example, that is the class name, followed by the function which has a static keyword. Even with respect to count, you need to take the class name dot count. Now, where do you think this is useful? Whenever I create any object, the first function it is going to call is the default constructor. If it is present, otherwise parameterized constructor. If not, then it is just going to allocate the memory. Now here what I'll do is I'm going to increment this count. Every time an object is created, I'm going to increment the count. Also, I'll take a separate data member, let us say int my data, and I'm going to give it as initially as 0. And here I'm going to make it as my data plus plus, and will print out count and my data probably. Okay, whenever an object is created. Now see what happens. I will create one object. Now this one I'm going to remove. I'll create one object of example. So it will be example E1 is equal to new example. Okay. Now when I do this and run this function, basically what happens is this will call the constructor here. So count plus plus means initialized to 0. My data is initialized to 0. Count will become 1. My data will become 1 when you run this. Okay. What I'm going to do next is I'm going to take another object. I will make this as E2. I'll make this as E3. Now if you run this, you will notice that the count went on incrementing because count is not part of individual object. Count is a part of the class. So what happens basically is, let me explain you with the Excel sheet. So in this, imagine we have taken a static count. Now count is part of example class. Okay, that means this count is part of all the objects which we are going to create. So count initialized to 0. Now you created even. When you created even, automatically even gets its own data member, which is the data member my data. Count will be allocated only once. Any number of objects you create, it will have access to that particular address. Now my data is equal to 0 is a part of this object. So you will have even dot my data, and that will be equal to 0 initially. And when it calls the constructor, what happens? This gets incremented, and the count, which belongs to the example class because it is a static variable, this gets incremented to 1. This is one object creation. When you created second object E2, E2 also had uh, my data, which is initialized to 0. Because if you notice here, count is 0 and my data is 0 initially. But the moment it goes to the constructor part, right? Here, what happens is it is going to increment this to 1. Okay. But the count was already 1. So the count will be equal to 2. Now, in the same way, when you give E3, that means my data is a part of this E1, E2, and E3. There is separate memory allocated for my data for E1, separate memory for my data E2, and separate memory will be allocated for my data E3. But the moment you created this, this became 3 because all these objects right now are going to point at this one. When you say static count, no, all these three are referring to same count variable, and this count variable, there is only one memory allocated, and any object, if it accesses, it will have the same data. It will not have its own copy of count every for E1, E2, E3. All these objects that are created with respect to example will have only one copy for the count. That is the static keyword difference. So now when you ran this, basically what happened is initially count was 0, and when it came here, count will be incremented to 1. And my data is a part of this particular object even. This is by default converted to 1. Second object when you're creating, count is already 1. 1 plus 1, it becomes 2 because I told you all three objects are referring to same memory location here. Okay. This is static keyword usage. Okay. Now, if I want to call that display function, I'll just use class name dot display. Why? Because it has a keyword called as static. Okay, fine.